going to be a short video on astronomical data tracing. I won't dive into advanced or intermediate concepts in very, very short video, and I will guide you through the basic concepts of data processing. So, for this target, like today, we are going to process M104 galaxy observed by Hubble Space Telescope, and I've got the data from MAST, which is a multi-mission archive where you can search for the data, then you can easily get the data. It is a public archive, so good luck with it. I'm not going to cover the how to use MAST archive. Like it's very easy to use, so you can easily figure it out. So I've got three data sets, all observed by ACS camera, ACS Instrument Onboard Hubble Space Telescope. Sorry. So there are three channels. Like all are wideband image, as you can see. It's www. So they are wideband images. Okay, so let's open it up. For opening FITS image, like you can do a lot of things. You can either do it from Python, you can either do it from FITS Liberator developed by the ESA and NASA team, or you can easily do it on DSN. All are free. I recommend using DSN, even though it's a bit difficult to use, but it contains a lot of different parameters which you can easily tweak to get best of your images. Okay, so what I have did, like I have gone to scale and selected log parameters. Like these are different stretching functions. Like basically, FITS image consists of like some numerical data that represents the whites and blacks. And now, but those data are not enough. Like as you can see, if it is linear, like we see no data. But if it is logarithmic scale, you can see a lot of data coming out. And now, what we're going to do is we're going to tweak the parameter. So this is the right slider and this is the left slider. We usually don't need to tweak the left slider because like all are always set to around 0, and that works almost fine. We are going to tweak with the right slider, and as we tweak with it, we see like the data is coming out. Okay, so what we need to keep in mind, like don't stretch it too high because what it's going to do is like going to blow out the highlights. As you can already see, the code is starting to blow out. And moving over here, like you can see, like these here you can see like there is small line. This is nothing. This is just to electron overflow on the sensor. So we can easily fix it in the post processing. Okay, and here you can see like the data contains a bit of artifact. This is all due to like electron overflow or some instrumental errors, and this is always going to be in the data. But we can always fix this. So don't need to worry about this right now. Here like we're going to look at the basics, like what are the things over there, like what we can look at it. And here you can like easily see like there are small galaxy over there. This is the M104 galaxy, and you can see like a dusty spiral. It is not a phase-on galaxy. It is like kind of Asian galaxy, the Asian galaxy. Okay. So let's save this. Export. I prefer to save this as TIFF because the retail loss will be very less. Don't go for image compression because you will lose details over there. It will take some time to save the data because it's a large file, so don't worry about it. Uh, Now we are going back to Photoshop. Like for making RGB image, like you need some image editor, like some advanced image editor, and I prefer to use Photoshop. You can use GIMP also. That also has the same functionality. But I prefer Photoshop. If you don't get Photoshop, you can always use GIMP. I have browse the files and then so here are my three files. I will load it in. Okay, so my files are loaded over here, and now the basic concept of image processing is Like this number represents the wavelength at which the image has been taken at, like 625. It's an optical range and 625 nanometers. So how we are going to assign colors, right? Lower the energy, higher the higher we map it into optical spectrum. So like here we're dealing with the optical spectrum, so we don't have any difficulty. We can easily map this 625 to red, 555 to green, and 435 to blue. Lower wavelength means higher energy, and we all know like blue light is higher energy than red light. Okay, so like if you're doing with some, let's say, X-ray image, okay, and like there is no wavelength specified, but it comes in energy like 5.3 like kilo electron volt, etc., etc. So higher energy goes to lower wavelength in optical range. So if it's 8 kilo electron volt energy, it will go to blue color. If it's 5 kilo electron volt energy, it will go to green color. And if it's 2 kilo electron volt energy, it will go to red color, right? It is not an necessary that electrons like it will all be in like 5, 8, and 2 kilo electron volt. It can be anything, but basic concept is lower energy get maps to lower higher colors. Okay, so before we do anything to this, let's just take like whether our thing is it's RGB image 8 bits. And so what we are going to do is open this up. Now we need to map it to red color. So deselect green, deselect blue. Okay. Now for 555, we are going to red, we are going to blue. Now 435, we are going to all this. Okay. So now what we can see over here, the image that appears to be reduced. And why? Because for the 625, the levels, the white levels are too high, and we can easily tweak with it. Now, I always prefer to do it in a non-destructive manner. And what we can do, like, we can just bring this a bit down, bring this red highlighter down, okay, and then and see in the background we're getting kind of blue halos. Now, you gotta be very careful with these adjustments because like, if you pull them too down, the images over here will be blown out or some different gradient will come in. Now, I always prefer to do it in non-destructive manner. So I never make it destructive now. It's green, so I will pull down the green a bit too. Now, taking care of this gradient, this can be very difficult, right? Sometimes it can be very difficult. And coming over to this like optical post over there, and this thing, like we can easily take care of this thing, but these things are a bit tricky to handle with. I am not going to cover it in this video because like it will be very long. What I'm going to do is just give like how to do it. So we are going to the channels section of Photoshop. Here you can see red, first photo blue, and we can see like blue things. We can easily fix this by making a level adjustment that is only applicable to this portion, and so this will remove this part. Similarly, we are going to do it for the green, and in the same manner, we are going to do it for the red channel, and then it will fix this. So I'm going to be there. Now I'm going to make some fine adjustment and to fix this blue yellow over there. So let's carry on. Uh, I'm going to go to the mask and then take my brush and then increase the size of it. Increase a bit, make sure it's white, then start painting over there. Don't go too hard with the opacity because like just go with gentle. That's better. This is the camera picture. Or what you can do like go to the curves adjustment and then have a look at this. Like if this is white, like all the things, all the colors are falling. We know this is good. Okay, even though this is not falling in, but the colors are pretty coming out pretty good. Now, what we need to keep in mind is it's not always going to work like if this white is handling like this. You have to always look like, let's say, you only two filters or like two data sets, like one from the blue wavelength and one from the red wavelength. So you need to create synthetically the third image. That all comes into like advanced processing, but like yeah, we can do it. And that time that this looking at the histogram, it's not going to be the best what you have. So yeah. See, here, okay, interesting. But yeah. See, like what we can get from the basic images over here, like with just planes are coming out good. Now we can easily do like different methods like scene masking or like bring out the faint details, or we can apply high pass filter for the bring for bringing out the faint details. Now how we're going to face this thing, I'm going to show you quickly, very quickly. Just select the spot because like almost like every hour when there is like some part of the sensor like where electron overflow happens. These are just basically an instrument so you don't need to worry much, but like yeah, you can easily fix this to make the image appeal. And we have blown out area, like so we're going to like paint over it white a bit. Uh, so yeah, it looks like a passing star now. Taking a lot of advanced concept and how to discover it. Like if you think the image is too blurred out, like because of deconfiguration, that recovers the details from the blurred out images. Right? I'm not going to cover this in the video, so yeah. I just now need to make a fine adjustment. After that, you will see it's good. Like I will take care of this getting like to know like whether there are like some gradients over here or not. I do like I do equal and see like there are a lot of blues and some of red over here. So now what I'm going to like I'm going to take care of the gradient. No, it's a bit like because like if you see like we have to keep on checking like whether they're gradients or not. Like their advanced software like they can sense it very good solve it easily. But like yeah, I prefer to do it in Photoshop also because Photoshop gives you a lot more flexibility with the thing that you can do. So after this, so yeah, so I'll keep working. And so now I didn't fix the filter box over it. I did crop the image a bit to remove the unused parts, and so yeah, I didn't fix the electron overflow too because that all comes under advanced concepts. So yes, thank you. Usually like the screens over here pretty much covered. The screens over here, the screens are lower. Now, sometimes it will reduce a bit noise over here, like because you can see in comparison to this image is very smooth, right? But yeah, this image this is not that much smooth.